everyone, let's talk about gram-to-gram stoichiometry. Let me begin by saying you've already practiced with mole-to-mole stoichiometry, and this is just an extension of that process. The downside with using moles is that we can't actually measure a mole. I can't walk back into lab and measure out, scoop out 1 mole. When we are in lab, we measure things by how much they weigh, their mass. I don't have a molometer, I have a balance that'll tell me grams. And so what we need to do is we need to take your mole-to-mole stoichiometry skills and we need to add the gram piece. So we're going to combine 2 things you already know how to do. We're going to combine gram-to-mole conversions, or mole-to-gram conversions, depending on which direction you're going, and mole-to-mole stoichiometry. So there's actually nothing new in today, we're just putting the pieces together. So here is your plan for gram-to-gram stoichiometry. As with all stoichiometry, you must always start by writing and balancing a chemical reaction. That has to be first. That's your recipe. That's going to tell you how much of each of the different chemicals you need or will form in your reaction. Then you're going to look at your problem, and any value that's given in grams, you're going to convert it to moles. Once you have the moles, you'll use your mole-to-mole stoichiometry skills, keeping things organized in a BCA table, and you'll convert from moles of one chemical compound to moles of another chemical compound, the one you're interested in. And then we'll take that final number of moles for the chemical that we were asked about and we'll convert it to grams using your conversion skills again. So, as a quick little streamlined piece here, we're going to go from grams of the first chemical to moles using the molar mass. Then we're going to go from moles of that chemical to moles of our target chemical using the mole ratio. This is where we keep things organized in a BCA table. Once we know the moles of the chemical that we were asked about, we'll convert that to grams using the molar mass. That's our plan. I'm going to do 2 examples. The first one I will do using proportions, and the second one I will do using dimensional analysis. First example, how many grams of water are produced when 14 grams of hydrogen gas reacts with excess oxygen gas? Always have to start with a balanced chemical equation. So in this case, I am taking hydrogen gas, and I am reacting it with oxygen gas to form water. And in order to balance this equation, I'll need 2 waters and 2 hydrogens. First step, balanced equation, check. I'm going to prep my BCA table, but not put anything in it yet, because BCA tables must be in moles. And what I'm told is how many grams of hydrogen gas we have. So the second thing I will do is I'm going to convert grams of hydrogen gas into moles. At this time, I know my moles of hydrogen gas. I'm going to keep things organized using my BCA table. And I want to use up all of this hydrogen gas. So my change line will be 6.93 moles, leaving me with no hydrogen gas when I'm done. The question was asking how many grams of water are produced. And I know that I have excess oxygen gas. So I know I don't start with any water. I just need to figure out the change, how many moles of water will be formed. And this is where the mole ratio comes into play. So I'm going to do this again using proportions. And this is a 2-to-2 mole ratio between the H2O and the H2. So if you can do that by inspection and say 2-to-2 is 1-to-1, my number of moles will be the same. Awesome. Otherwise, down in pink here, I have the conversion using proportions showing how I went from moles of H2 to moles of H2O. I'm going to add that to my BCA table. And this means that I'll make 6.93 moles of water. I've now completed the next step. Only one remains. This question asked for how many grams of water were produced. And so now what I'm going to do is I'm going to convert from moles of water to grams of water using the molar mass of water. And this gives me my final answer of 125 grams of water. Quick note on significant figures. You will want to be using your original starting mass for your significant figures. You should have enough decimal places in your molar masses that those should not change, and your mole ratios are exact. So your final significant figures should be determined by that starting number of significant figures in your problem. Let me work a second example. This one, I'm going to do all of the conversions using dimensional analysis. But we always start in the same place. We need to start with a balanced chemical equation. In this problem, I've got 36.5 grams of zinc metal reacting with hydrochloric acid to produce zinc chloride and hydrogen gas. So my balanced chemical equation, I have zinc, and metal is a solid. It's reacting with hydrochloric acid, which is HCl, and that is aqueous. And this is forming zinc chloride and hydrogen gas. This equation is not currently balanced. I need to put a 2 in front of the HCl in order to balance the equation, but now we're set. Again, I'm going to prep my BCA table, but not put anything in it yet because I don't yet have moles. First step, balanced chemical equation. Second thing we're going to do is we're going to turn the grams into moles. So in this case, I've got 36.5 grams of zinc. I'm going to convert this to moles of zinc. The molar mass of zinc is 65.38, so I'll need to divide by that value, and I get 0.558 moles of zinc. So this is the amount of zinc that I started with. That'll go on my before line. And I know I need to use it all up because it's supposed to react completely, so I'll have none left over. And then I am being asked about how much HCl that took, how much hydrochloric acid. So the second thing I'm going to do is I'm going to use the mole ratio to convert from moles of zinc to moles of HCl. And when I find this mole ratio, it is a 2-to-1 mole ratio, looking up at the coefficients in my balanced chemical equation. I find that I need 1.12 moles of HCl to react with that same amount of zinc. And since I wanted to use that HCl up all of the way, because it just said how much is needed to react, that means that must have been the amount of HCl that I started with. So here's my moles of HCl. Now, to note, this problem didn't ask about zinc chloride and hydrogen gas, so you can definitely fill out the rest of the BCA table if you want, but it's not necessary to answer the question. The final step we need to carry out in order to answer this question is to take the moles of HCl and convert that into grams, because the question said what mass of HCl is needed. So again, I'm going to set up a dimensional analysis problem. I will use the molar mass of HCl, which is 36.46 grams per mole, to do this conversion. And I find that I need 40.8 grams of hydrochloric acid to react fully with this amount of zinc. So in summary, there are 4 steps. First, balanced chemical equation. Second, convert grams to moles of the chemical you're told about. Third, convert from moles of the chemical you're given to the moles of chemicals you want using your mole ratio. And fourth, convert from moles of the chemical you were asked about back to grams using its molar mass.